Assalamu alaikum. I am Neema Tahir and I am the student of MS Chemistry in UMT Sialkot. Today the topic of my presentation is application, working mechanism and implementation of fiber optical sensors in current innovation. Today I am excited to talk about this topic because it is very crucial in the present age. First of all, we talk about the abstract. This review article actually provides insight that explores the fundamental and application of fiber optics, highlighting its historical development and essential components. Fiber optics, based on the principle of light transmission through glass or plastic fiber, offers significant advantages in speed, efficiency, and immunity to interference. Actually, the article examines the structure of optical fibers, including the core, cladding, coating, and termination role in signal property. It further discusses the frequency-based methods, the diverse applications in pavement engineering, biomedical monitoring, heart rate tracking, and chemical sensing are reviewed in this article. Additionally, the role of fiber optic sensor is emerging technologies like biomechatronics and machine learning is highlighted. Now we talk about the introduction of optical fiber sensors. The optical fiber sensors are considered a remotely important tool. They are used for gathering information from different mediums by detecting and analyzing light properties at specified electromagnetic spectrum ranges. The spectrum includes diverse regions such as ultraviolet, infrared, and visible regions. When one or more light propagation characteristics such as wavelength, frequency, amplitude, phase, intensity, polarization will be artificial by the measurement of physical, chemical, or biological phenomena. And this review article actually explains the function of an optical fiber sensor to measure some physical, chemical, or biological parameters that transmute some optical property of the system. Optical fiber has positive properties such as being lightweight, small in size, low in cost and having low lessing and immunity to electromagnetic interference, making them a perfect sensing medium for a wide variety of real-world applications. By examining and analyzing the information collected from this sensor, we will track and screen changes that happens at different angles in our lives. For case but not restricted to temperature, humidity, and gas sensors give much data around the climate which contributes to including the cause of changes that happens within the environment. Medical sensors provide information about the vital sign of individuals which contribute to their medical diagnosis and reduce the spread of epidemics. Moreover, information may be collected through social media around people to get in their behavior and their interface and adjust this within the promoting of a few companies' items. Motion detection sensors and thermal sensors offer data on activities and changes or movements that take place in a specific environment and hide this in maintaining the security system. Many sensors are employed in the field of industry and civil construction. There is no doubt that digital transformation and the general tendency to create smart cities, automate systems, and employ the ultraviolet, infrared, and visible region in numerous crucial ranges in different viewpoints of our lives, such as well-being, care, farming, environment, transportation, industry, and security, driven to sparing time, exertion, and cash. By employing these technologies, the most appropriate decision in the least possible time could be taken by the decision makers. And as you see that the all the references are already there, you can check this on the website. Fiber optical sensors have several applications for passively detecting the physical property of earth materials. These sensors can sense physical properties including pressure, temperature, vibration, strain, physical displacement, light intensity, rotation, magnetic field, electric field, radiation level, fluid flow, and liquid level. Despite the vast potential, only a few of them pressure, temperature, vibrations, and strain and have field tested and well demonstrated during the last couple of decades and thus considered as standard capabilities. The field experiments have mainly taken place in the oil and gas industry with minimal educational institution work. Field tests are contained of point pressure sensors, distributed acoustic sensors, distributed temperature sensor DTS, distributed pressure sensor DPS, and distributed strain sensor DSS. The DAS, DTS, DPS, and DSS detection technologies are based on Brillouin, Raman, and Rayleigh backscattering of light and fiber Bragg grating techniques. These distributed sensors have been applied in mining, geothermal studies, earthquake detection, landslide detection, and prediction, hydraulic fracturing, and tunnel construction. Field tests utilizing fiber optic detecting innovation for geophysical applications are expanding and their outcomes about have been displayed at a few conferences. The innovation has been connected at dispersed angle parameter locators and multi-parameters half-bridge sensors for near-surface and borehole geophysical overviews. Its capability to integrate more than two fiber optic sensors to detect two or more physical parameters simultaneously is a tremendous advantage of the technology. Fiber optic sensors offer various unique benefits, including high response rates, low fabrication cost, lightweight, high sensitivity, and non reactivity to electromagnetic interference. Moreover, the optical fiber sensors capacity with low signal attenuation, flag weakening, low flag retention, tall transmission capacity, and tall bit transmission renders these sensors perfect for geophysical applications. In any case, it has not been well misused in geophysics and advancement or alluring. In this way, remote the geophysical community has not taken advantage of these present day detecting procedures. There is little in terms of review literature showing that fiber optic technology is an essential, modern, and comprehensive branch of geophysics. In short, working mechanism and operation of fiber optic sensor in the current technological landscape highlight their growing importance across various sectors. With their ability to offer landscape highlight their growing importance, high accuracy, real-time monitoring, and immunity to electromagnetic interference, these sensors are increasingly becoming a key solution in fields like telecommunications, healthcare, and industrial monitoring. As advancement in fiber optic technology continue to evolve, these sensors will likely play an even more vital role in enhancing system performance, reliability, and safety. However, challenges such as integration with existing infrastructure, cost consideration, and the need for focused knowledge remain. Nonetheless, with ongoing research and development, fiber optic sensors are well positioned to meet the demand of future applications and continue to convert industries worldwide. Next, we have to discuss the second point of our review article, which is the fundamental of fiber optical sensor. Now we talk about the historical perspective of optical fiber sensors. Fiber optical sensors are also illustrated as FOS, are used for assembling evidences from the surrounding medium by detecting and analyzing light physical characteristics at specified electromagnetic spectrum ranges. The spectrums actually contains different regions such as ultraviolet, infrared, and visible region, where one or more light propagation characteristics such as wavelength, frequency, amplitude, phase, intensity, polarization will be affected by the measurement of physical, chemical, or biological phenomena. More than 60 years had been considered in developing optical fiber sensors. The core reason for the relative delay in the prosperity for the manufacture of these sensors and the spread of their application in the urgent need for advanced technologies to manufacture them. as well as the manufacture of notable light sources, modulators, waveguides, and detectors. In addition, 1961, the term optical sensors first seen in a publication of the Optical Society of America, OSA. At the start of 1980s, researchers were interested in the technology of interference fiber optic sensing. After that, in 1986, the Optical Fiber Sensor Network (OFSN) distributed and quasi-distributed optical sensor had emerged, and at the termination of the 1980s, the researcher absorbed on the fiber Bragg gratings technology and its important role in the progress of the fabrication of OFS, which runs to the appearance of new goods such as optical radar, which depends on optical time domain. Reflectometer, also Raman distributed temperature sensor, had seemed at the end of the 90s. Techniques of Brillouin sensing characterized by Brillouin optical domain reflectometry BOTDR and Brillouin optical domain analysis BOTDA became commercially available after the beginning of 2000. There were successful in optoelectronic device and signal processing technologies. All of these developments led to the finding of a new application of different sensors such as Fabry-Perot interferometer FPI, OFS, FPG sensors, and distributed OFS. Now, at the initial of 2000th century, there was a promising new optical fiber called photonic crystal fibers that contributed to the development of the biophotonics scientific sectors and also to grow and innovate new devices in the industry sector like wideband optical sources and new sensors. Now we have to talk about the structure, coating, and termination effect of optical fiber sensors. A characteristic single mode telecommunication cable is contained of a silica gel, a glass fiber core, and a glass cladding of a lesser refractive index. This allows for total reflection and the light to travel over the entirely of the fiber with the small losses. For mechanical purposes, a layer is applied to the glass fiber during the production. Often a dual coating approach is used. Both coatings are typically based on UV cured polyurethane acrylate resins, and the primary coating is commonly soft and elastic, while the secondary coating transport additional thickness and stiffness. And here is this diagram of optical fiber sensor cladding. Now you can see that fiber optical cable, it is the connector, the termination core fiber and steel, and the jack on connector side, fiber optical center and backscatter. Okay, and this is the connector. It is multiple jackets which it can be prepared for the protection, for additional protection of it. It is made of polyvinyl chloride or low smoke zero halogens. Now this is the diagram, as you can figure it out. The length of the outer sleeve is slightly shorter than the fiber inside. This allows for installation of cables under some tension without risk of optical fiber snapping easily. In contrast to a telecommunication cable, a DOFS, as shown in the figure 2, which we can see here, is less threatened from the environment because it is meant to interact with it. Structure of a fiber optical cable or Ethernet cable and FOS in contrast with each other. Public acrylate coatings are used in temporary range from -40 degrees centigrade to 85 degrees centigrade, while polyamide coatings can withstand much higher temperature, up to 300 degrees centigrade. Because of these polyamide coatings are more frequently applied in FOS, it has been shown that dual acrylate coated fibers can resist up to 150 degrees centigrade when a hydrogen scavenging gel is used. Now we have to know that how optical fiber work. This is the source and this transducer. Optical fiber are placed here. This is the measurement and detector which can process electronic processing. Now we have to know what is optical fiber sensor components. From the prior section, it is very clear that the main point of the optical fiber sensor construction are three parts: optical source, modulator, and optical detector. Now we talk about their components. Optical source. There are many diverse light sources are used in the industry of optical fiber sensors. Some of them are listed: light emitting diode LED, low cost and available in always more spectral ranges from UV to infrared using a new semiconductor. Superluminescent diode, more powerful than a classical LED. More generally, a lot of progress has allowed increasingly the LED output power. The coherent light amplification by stimulated emission of radiation diode, available in always more spectral range from UV to infrared. Its cost has decreased and its power could be controlled. Vertical cavity surface emitting laser VCSEL is more powerful than standard laser D, but less coherent and is often multi-mode. Next point is optical fiber. There are now many different types of optical fiber cables, such as single mode and multi-mode structure with different core diameters, dimensions from a few micrometer to a few millimeters. Some of them are listed here. Stop index and graded index fiber could be made by using several different indices. Polarization maintaining fiber PMF has different designs for making birefringence in the fiber. The main three types of PMF are elliptical clade, which is called oval inner clade fiber, panda shape, and bow tie. Photonic crystal fibers is a promising type of microstructure fiber in the direction of radiation. Fibers are fabricated from different materials such as polymer or silicate or silica, which is doped with different dopant material like fluorine, erbium, germanium, and aluminum. Bragg grating fiber refractive index is regularly modulated along its length. The next part is optical modulator. To get familiar with this very important part of optical fibers, we must also know its working principle and its three different types. This part of is responsible for transmitting several influences from the surrounding environment to be monitored. As we declared previously, the external influences affect the optical properties and the method of the light propagates within the optical fiber. That is why it is so important to choose the right modulator which contain the sensing and transduction elements. To be sensitive to be required external influence or phenomena which want to be detected and monitored. This point will be covered in this section on the classification of optical fiber sensors. As we can see here, fiber optical cable with an outer jacket. This is called the outer jacket of fiber optics. This is the strength member which can tensile its strength and protect it. This is cladding, and this is the coating part which can protect it from harsh weather, and this is the core of the optical fiber sensor. As we can see clearly, this photo can evaluate everything in it. Next, we have optical detectors. Because of the existence of many different types of optical fiber sensor, it is reasonable that there will be also different types of optical detectors which will rejoin only to the optical energy. This energy is linked to the optical parameters of the light wave such as amplitude, phase, polarization, and frequency. Each definite type of optical fiber sensor has its need to sense the perturbation depending on the moderated optical parameters which will be measured. There are diversities of optical sensors such as the photodiode, APD, and the photomultiplier PMT. For example, a photodiode could be used directly for intensity measurement or could be used with other devices such as polarizer and wave plates for determining the polarized state. Here the references are mentioned here. You can check it in the last section. Operating principle of fiber optical sensor. Light has a duality property. It consists of particles called photons or its electromagnetic waves in which the electric and magnetic fields are perpendicular to each other and to the direction in which the light travels. Intensity. based optical fiber sensors. How it can work, we can talk here. The external influences in the environment could be of transmitted lights. There are many techniques to measure the intensity, but the foremost three intensity modulated sensors are transmissive, reflective, and macro or micro band type. Many diverse optical components such as lenses, mirrors, and prisms direct the light to the desired point of the measurement. This is also done with the help of several their optical devices such as beam splitters, isolators, connectors, and couplers. Also, multiplexing techniques could be used if there are multi-point of sensors. Here you can see the perturbing field measurement, light intensity modulating devices. This is the light source and detector which can process the signal here on the monitor screen. We have to know about phase-based optical fiber sensors. This is the second type. This type of optical fiber sensor is based on phase modulation and is more precise and more delicate than intensity modulation. The foremost device which is used to detect or the modification in the phase is called an interferometer. The most frequently used are Mach-Zehnder, Fabry-Perot, Michelson, polarimetric, and grating interferometers. Its operating principle hinge on comparing the phase of light after splitting it and making an injection into two single mode fibers. One will be used as a reference and the other will be visible to the external perturbation, which will cause change or shift to the stage of the light signal. It is noteworthy that the phase vibration will lead to a change in frequency and wavelength of the optical signals. Frequency wavelength optical fibers sensors. This type of optical fiber depends on noticing the alteration in frequency or wavelength of the conducted light. This variation is caused by external perturbation. This device type of optical fiber sensor has different composition which are used in many areas such as fluorescent optical sensors, which is used in medical field, FPG sensor, which depend on grating of the refractive index periodically. Now we have to know what are the applications of fiber optical sensor. Now, first of all, we have to talk about the application of fiber optical sensor in pavement engineering. Optical fiber sensors attracted enough attention to the pavement monitoring area in the past decade. Multiple types of fiber optic sensors have been used for monitoring traffic data and pavement structure health information. It has been revealed that the strain, temperature, and pressure information of each structural layer of pavement can be measured in real time by using optical fiber sensors. Thus, optical fiber sensors becoming more important in road design, maintenance, and traffic planning. The commonly used optical fiber sensing technologies for pavement monitoring. First of all, here we can see the diagram. Compared with traditional sensors, optical fiber sensors have better corrosion resistance and electromagnetic interference resistance. Besides that, optical fiber sensors can be used for more than 20 years and a high signal to noise ratio SNR. Therefore, optical fiber sensors attracted through attention to the pavement monitoring areas. Now you can see here the mechanism of optical fiber in pavement monitoring area. First of all, here is the application research. We can zoom in. Road strain monitoring, road temperature monitoring, road deformation monitoring, and road pressure monitoring. All our applications are controlled by optical fiber sensors. Now here is the application research. Here again, road strain monitoring and its principal research, principle of FPG sensor and principle of DOF sensor. All the applications are same, but the processor management are different. Here is the optical fiber sensors here, and these types are different from each other. Embedding method are two: pre-installation method and post-installation method. The diagram show the distance along the fiber through a graph. Here you can see there on the vertical side strain transfer rate and on the horizontal side distance along the fiber. Okay, now we can zoom out. Next, we have to talk about the status, future development of dispersed optical fiber sensors for biomedical applications. Fiber optical sensors have long been acknowledged by biomedical societies and improved their integration into medical fields. Flexibility and high sensitivity make FOS perfect for robotic manipulators, tissue preparation during minimally invasive surgery, and strain measurements. Here is the diagram of schematic to operation fiber brick sensors and its response to external stimuli by biomedical applications. Here is the coating, cladding and core as we can discuss in the optical fiber. Here is the coating, cladding, and it is the input. Okay, here is input and it can be reflected back from here or it can transmute it against it, the wall of the coating. Here before external stimuli its review is this, and after it can show this. Its wavelength is measured in nanometer as you can see here clearly. Now we talk about the probability and immunity to electric and magnetic field of optical fibers can be advantages for monitoring physiological activity and treatment procedures during MRI scanning. In addition, the ability of fiber sensor to embed into composites allowing the monitoring of human activities and the measurement of pressure during the prosthetic treatment. Multiplexing and the possibility of enhancing the performance of FOS expand their application for biomedical purposes. Providing non-hostile measurement is also excessive benefit for FOS over conventional sensors. Now we have to talk about the second application of the optical fiber sensors. Optical fiber sensor for heart rate monitoring. With the growing public concern about personal health, the monitoring of vital signs which include heart rate HR, respiratory rate RR, blood pressure BP, body temperature and other signals is becoming more and more important. Generally, the heart rate, HR, and signs related to cardiac activity can be obtained in the following 5 ways: ballistograph, ballistocardiograph, BCG, electrocardiograph, ECG, pulse wave, PW, phonocardiogram, PCG, and apex cardiogram, ACG, which shown in the figure. In HR monitoring application, intensity modulation is the most easily realized optical fiber sensor modulation. However, the low signal to noise ratio SNR and comfort of interference with intensity based OFS must be well thought out. Therefore, additional operations to optical fibers such as twisting or polishing are usually required to growth. The understanding to strain other methods such as adopting specific filtering algorithms to here. Here we can see the pulse wave of the human body, SCG or ballistocardiograph, electrocardiograph, and PCG. This area of the heart show the ACG of the human body. CA is for carotid artery, BA for brachial artery, FA for finger artery, RA for radial artery, and DPA for dorsalis pedis artery. Extract relatively weak HR signal from the spectrum. Now, these are the 5 cardiac activity monitoring methods. Here are described here. Its graph can show this, and BCG graph show this in lot of ups and downs, and this is the ECG graph which show this. If the person is dead, it can show the mountains from in a intensity level is high, and if the heart rate is down or dead, the line show in a single wave. Next, we have to talk about the blistocardiograph. It is a type of micro vibration caused by human heart activities. It is non-invasive signals which can be composed by detecting the mechanical signal from the patient's corporal contact platform when the heart pump blood, it hits the blood vessels, generating focuses in the opposite direction of blood flow, which are then transmitted to the body's surface. By analyzing the BCG signal, the cardiovascular system health and synchronous data of cardiac hemodynamics can be reflected. Next, we have to talk about the electrocardiograph. An ECG obtained cardiac activity by measuring the bioelectrical information of the heart. When the heart contracts, it produces tiny electrical pulses promulgating through the myocardium. When the heart contracts, it generates tiny electrical pulses propagating through the myocardium. ECG can be gained by monitoring these bioelectrical pulses. The pulse wave PW measurement method is to roughly estimate the HR by detecting the pulse time of the large arteries, such as radial arteries and the carotid artery. In general, HR can be estimated from the pulse. This process is simple and suitable, but if the patient has an arrhythmia, the measured pulse number will be different from the heart rate. Next, we have to talk about the phonocardiogram. Phonocardiogram measures mechanical vibration produced by myocardial contraction, valve opening and closing, blood rushing, supplementary factors in the cardiac cycle. With the ECG, PCG can measure mode heartbeat information such as the third heart sound, which reflect the speedy left ventricle distension along with an increased arterioventricular flow. Apex cardiogram. Apex cardiogram ACG is the recording of movement of the chest wall over the apex of the heart. Apex pulsation will cause chest wall movement. Consequently, the pressure sensor sited on the chest can measure the apex peak to get an HR signal. Here we can see that intensity based, interference based, specklegram based and FPG based, its cost and complexity and its accuracy. The intensity based optical fibers have low cost and low complexity with low accuracy, and interference based medium cost, medium complexity and medium accuracy. And here is the specklegram based, its cost is low but its complexity is medium. FBG based have everything are high cost, high complexity and high accuracy. Here we can know how FBG are important and valuable. Now we can talk about optical fiber sensors for chemical monitoring and analysis. This is the fourth application of optical fiber sensor which we can talk here. Optical fiber sensors are predominantly suited for chemical monitoring and analysis due to their ability to withstand harsh working conditions, and their small volume and inactive nature allow them to have minimal impact on the environment. At the very beginning, fiber optic chemical sensors exploited optical fibers just as a transmission medium to guide the light to and from and the sensing region. In this type of arrangement, known as an extrinsic optical fiber sensor, the light is changed either via direct interaction with the analyte or with a sensor component outside the fiber that has some belongings that varies in the presence of an analyte. A property of fiber optics chemical sensors is their capability to be multiplexed onto a single fiber, allowing measurements causing large scales as mandatory by applications such as those in the oil and gas industry and for the environment monitoring. Such multiplex sensors are normally also referred to as quasi-distributed sensors since they are not capable of Since they are not capable, such multiplex sensors are not capable of manufacture measurements at predefined points, and any variation of the analyte among sensing point is mercilessly missed. Otherwise, for fully distributed chemical sensors, the whole fiber is analyte and sensitive and therefore proposals. Here is the diagram. This can show the inlet and outlet of the fiber optical sensors. These are the injections. Now we have to talk about the remaining part. The core sensing mechanism behind any distributed chemical sensing scheme is common with the corresponding point fiber chemical sensing technology. In the distributive form, spatial resolving over long distance is achieved through the application of well-established optoelectronic techniques. And the diagram shows the analyte arrives the ear hole through fiber ends. This and the analyte arrives outlet and the inlet of the fiber optical sensor. Now this is the fluorescence measurement is a very sensitive chemical sensing technique. When a fluorophore interacts with an analyte, its inflorescence property can be modified in several different ways, including intensity, lifetime, wavelength, or polarization. The fluorophores were placed at the fiber tip in fiber cladding and even in fiber core for pointing sensing. For the later approach, dopant fluorophores in the core are excited by the discharge from analyte sensitive fluorophores in the cladding. Also, this method enables higher fluorescence intensities in the core. Fixing both the cladding and core is challenging. As a result, fluorescent cladding seems to be the only practical choice for dispersed fluorescence measurement. PCS fibers are frequently used for this method. For allocated fluorescence measurements, OTDR is used for sense the local optical power change in the presence of the analyte. The first generation of such sensors requires an external illumination or to excite the fluorescent dye in the cladding as depicted in the figure 9. This is the cladding and this is the core, and analyte is fluorescence. This is fluorescent surface here. Here we can see the excitation. Excitation can start from here, and this can hit the analyte and it can pass through the fluorescence sites. This is the excitation of the fluorescent dye. Now we can talk about the fiber optical sensor, an assessment of current innovation. Here we can see that how fiber optical sensors can be used in current innovation. Fiber optical sensors for biomechatronics. Biomechatronics is an interdisciplinary scientific field that emphasizes the integration of biology and mechatronics to discover innovative solutions for numerous biomedical applications. The broad application spectrum of biomechatronics consists of minimally invasive surgeries, rehabilitation and development of prosthetics and soft wearables to find engineering solutions for the human body. The current emphasis of biomechatronics research revolves around the application and activities in humanoid and bio-inspired robots, such as human-robot interaction, prosthesis, endoscopic system, minimally invasive MIS, and physical parameter monitoring, health monitoring, and rehabilitation. The measurement system that detects physiological parameter variation is one of the most vital components of biomechatronic system. Ali Najafzadeh et al. Examined the efficacious layout of FBG concerning the breakage position and implant plate for future work. For the intact femur, 3 FBG were placed close to the proximal middle distal region of the femur surface using adhesives as shown in the figure. A green stick fracture of 30° was introduced in the femur in added experiment and immovable using a 3-hole implant bone. As the figure illustrates, a plated femur with the 3 FPG sensor attached at different locations longitudinally lows to the fracture. 2 more FPG sensors were glued to each of the femur to comparison the fractured femur with the intact one. This is first FPG, second FPG and the third FPG. These are glued on the femur bone. As we can see here, intact femur with 3 longitudinal FPG attached at the proximal, distal and middle ranges. of the femur using adhesives to measure the strain in the bone. Now we can move next. Here we can see by zooming the diagram. Here is the posterior surface, middle shaft, and the posterior linea aspera. FBG in proximal, middle shaft, and distal surfaces. Here it can be glued at the 30° and a total of 7 coiled FBG employed in the last test to measure the strain. Now we have to talk about the fiber optical sensor in machine learning. Sensors have also been established to monitor aspects such as glucose stages, sleep apnea, and heart rate, among others, in the field of health. Development in sensor development having rapidly progressed in various fields of information where vibration, movement, and other parameters are monitored. These sensors have become more adjustable to contextual needs, cost effective, and faster. However, recent advances in hardware such as optical fiber and software such as machine learning have changed the configuration of these sensors. Fibers such as machine, this allow them to more easily adapt to the specific needs of the context for which they are intended. As a result, various sensors have been developed for the detecting and monitoring physical and sensory elements. The development of various types of sensors have resulted in growth and detecting fire, water temperature, and movement, among other things. These sensors identifying anomalies in the input data received by the implemented system. Sensor designs has evolved to include features that provide greater precision in operations. Bioelectrical, biophysical, and biochemical signals can be employed in various contexts, including sports development and medical analysis and prevention, as well as rehabilitation. Sensors play a crucial role in risk prevention, including health, road, natural, and architectural risk. It is important to design, manufacture, and implement sensors in the numerous contexts to mitigate these risks. To discover the application of machine learning in the field of optical science, bibliometrics uses a set of inclusions criteria to guide the selection of articles for analysis. These criteria prioritize articles that have been grouping of machine learning and optical sensor in their titles or keywords. This combination is measured basic meta data to identify the thematic relevance of each study. This assortment strategy focuses on finding papers that specifically address the connection between two cutting-edge technological areas. This encourages a detailed and specialized examination of their evolution, trends, and contribution to the field. The process of eliminating records contain of these phases designed to confirm the integrity and excellence of the sample analyzed. In the first phase, records with indexing errors are excluded to eliminate possible biases or inconsistencies in the composed data. In the second phase, a supplementary exclusion principle is applied specifically to a document without full text access. It is important to note that this criterion is only applied to systematic literature reviews as specified in the reference number 86 to maintain the coherence and reliability of the information available for this type of study. It is worth declaring that biobibliometrics is limited to metadata analysis as shown in the reference. Finally, the third phase of exclusive focuses on the exclusion of the conference proceeding due to their limited scope and methodological rigor compared to articles from specific journal. This ensures the reliability and quality of the document involved in bibliometric analysis. This rigorous methodological approach accepted in this study ensures the robustness and validity of the result obtained. Now we have to know what is the information source in this type and search strategy. Information source. The source of information for this bibliometric analysis correspond to scientific documents related to optical sensors and machine learning stored in the Web of Sciences scopes databases, which are the two most used databases for this type of analysis. What is the search strategy for bibliometric? to perform an efficient exploration in both databases so that all the keywords definite as presence criteria can be included. Two comparable specialized search equations are designed. First of all, it is the for the Scopus database title machine learning and title of optical sensor, or title for machine learning and optical sensor, and the keyword is for machine learning and optical sensor. For the Web of Sciences database, we have to search TI or TI machine learning or TI machine learning and optical sensor. What is data management? After completing the search strategy, we obtain a total of 189 initial articles from the Scopus and Web of Science database. Of these, 172 derived from Scopus and 17 from Web of Science. These articles will be extensively analyzed using specialized IT tools, including Microsoft Excel and the open access software VOS Viewer, which allow to apply bibliometric criteria that tend to qualify as measurable, objective, and multidimensional. Explicitly, we will use Microsoft Excel to perform a thorough analysis of bibliometric indicators, both in terms of quantity and quality. This tool allowed us to analyze various aspects, including the production of the main authors, the most important journal, and the leading countries in research on the topic. Now we have to talk about the innovative photonic sensors for safety and securing in current innovation. Photonic sensing technologies and optical fiber sensors are increasingly being used in new and emerging sectors for a variety of measurement and monitoring applications. Due to its characteristic widely discussed in this paper, fiber optic sensors are debatably the most suitable solution for harsh environment in which the temperature or strain monitoring is needed. But particularly since naked fiber grating FBG sensors are very thin, 100 of micrometer and light, it is very easy to embed them in many material them in the non-invasive way without altering the structure. Furthermore, FPG sensor can be smoothly used to measure temperature values around 0 degrees centigrade, monitoring the company of ice. The company of ice can be very dangerous in some circumstances, such as during the flight of an aircraft at a high altitude. During a normal flight, the borderline condition changes from a temperature of values of minus 40 degrees centigrade with 0 degrees and 0% humidity to high rate relativity humidity if moisture is present, provoking icing condition due to the wet air and enormously cold surface of the aircraft. Issues occur of the ice cross on the wing's imported edge, causing loss of altitude and engine problems. For the mentioned reason, the state of art, many companies and scientists are more and more focusing on the research of systems capable of avoiding these dangerous conditions. Our proactively removing the ice, many publications were completed the employing of air flux generated by the engine. Other solutions regard nanostructure air surfaces, aerofoil modeling, and short pulse laser surface. The composite material employed in it is carbon fiber, in which several conductive wires were inserted during the fabrication process. The FPG structure already used in some studies related to the carbon fiber in this study behave as a temperature monitoring sensor, indicating whether the temperature is high enough or if the temperature is declining excessively. After the introductory study, trained by a numerical simulation to understand the feasibility of the system, a test structure was fabricated and tested at the room temperature. Validation the usage of FPG sensor with the thermal imager. Here is the block scheme representing the proposed solution. Aircraft wing, leading edge heating wires, carbon fiber FBG sensor, and power electronic system. Here we can now discuss about. Hence, the system occupied principle can be defined as follows. The FBG sensor, which can be installed both inside and on the top of bottom outward of the carbon fiber, register the in time conducting wires through the Joule effect boosts the temperature of the carbon fiber, and the graceful current is provided and desirable, and it is not desirable anymore, which is the heat source. To prove the possibility of the system, the text structure was then fabricated according to numerical result. It was composed of 10 layers of carbon fiber material, each layer of 0.208 nanometer height, in area of 40 centimeter into 40 centimeter, almost 1600. Also embedding a stretch of fiber optic within the composite material, evaluating the final structure with non-destructive analysis. This led to thoughtful that the presence of the fiber optical does not mock the structure of the composite material, and that it is possible to insert a FBG sensor between carbon fiber layers. Now we have to talk about the marine application. Now, fiber optic hydrophones. A hydrophone is a sensor devoted to listener to underwater sound for civil or military application. Most hydrophones are based on piezoelectric transducers, commonly abbreviated as PZT, that generates an electric potential when subjected to a pressure alteration. Piezoelectric hydrophones presently have excellent performance but still have some limitations. PZT hydrophones are sensitive to electromagnetic interference, requires complex data acquisition systems, have poorly multiplexing capabilities, and are unsuitable for harsh environment. Fiber optical sensor technology characterizes a valid alternative explanation to conventional system for underwater application. The use of optical fibers lets the overwhelming of important limitations. In fact, fiber optic hydrophones are well lit, not bulky, but they have several potential rewards such as high sensitivity, huge dynamic range, small size, lightweight, and immunity to electromagnetic interference. Bucaro et al. Were the first to propose the idea of employing the optical fiber technology for developing hydrophones. And here is the reference number. Now, at the end, we have to know what is the conclusion of all the review article. Fiber optics have become cornerstone technology in multiple industries due to its inherent advantages over traditional electrical wiring, particularly its ability to transmit data at high speed over long distances with minimal interference. Its development has been shaped by continuous innovation from early theoretical concept to practical application in modern communication and sensing system. The core concept behind fiber optic, using light to carry information, has evolved into a versatile platform for a wide range of application, from telecommunication to specialized fields like biomedical diagnostics, chemical sensing, and structure monitoring. Next, we have to talk about the fiber optic structure design with precise engineering to ensure efficient transmission of light signals. The core cladding work together to guide light through total internal reflection, while the coating and termination processes protect and connect fibers in practical system. The property of these components such as refractive index, coating, durability, and connector quality greatly influence the overall performance and efficiency of fiber optic system. Fiber optic sensors, which exploits the ability of light to interact with different materials and environment, have become a key tool in many advanced technologies. These sensors operate based on different principles: intensity, phase, and frequency based. Intensity based sensors rely on variation in light intensity as a measure of external changes, while phase based sensors use the phase shift of light waves to detect more subtle variation. The frequency based systems are often used in more complex applications such as chemical sensing, precise measurement, where shift in the frequency of light signal can provide detailed information about the environment. Now then we talk about the application of fiber optic extend far beyond conventional data transmission. In pavement engineering, fiber optical sensors are used for real-time monitoring of stress, strain, and temperature, helping optimize road design and maintenance. In biomedical application, these sensors allow for non-invasive, precise measurement of diagnostics, monitoring physiological condition, and even enabling advanced surgical techniques. For heart rate monitoring, fiber optics offer a high degree of accuracy and reliability, enabling continuous tracking of vital signs without the limitation of traditional sensors. In chemical sensing, fiber optics are particularly effective due to their ability to detect minute changes in chemical composition in gases, liquids, and solids, offering a range of possibilities in industries and environmental monitoring. The ongoing innovation in fiber optical sensor technologies is driving forward the development of application in fields like biomechatronics, where fiber optic can provide precise and real-time data for prosthetic devices and robotic systems. Additionally, we have to talk about the integration of fiber optical sensor in machine learning in opening up new frontiers in automation, predictive maintenance, and personalized healthcare. Machine learning algorithm can analyze the vast amount of data generated by fiber optic sensor, extracting valuable insights and improving the decision making processes in various fields. In conclusion, the fiber optic sensor has transitioned from the niche communication technology to a versatile and indispensable tool in a variety of scientific and industrial domains. As innovation in optical sensor design and signal processing and machine learning continue, fiber optic will play an increasingly important role in shaping the future of technology, offering more efficient, accurate, and scalable solution for a broad range of application. Here are all the abbreviation used in the review article so that it can clear all the things very easily. Here I can mention them. Next, these are the references of the review article from which we can take it from. These are the review article. Round about 100 references are added in this review article. At the end, we have to conclude my presentation. These are the references, and this at the end we can conclude my presentation. Thank you.